Hi everyone, welcome to our video on finding the intervals of increase and decrease based on a rational function. So it's continued, so it's still this direction. So find the critical numbers and then we'll find those intervals. And it's still these steps, so it works out in a similar way, except we have a rational function, and so we actually have one other little thing that we do have to worry about, but we'll take care of that and it's really no big deal. All right, so for instance, let's break this down. Step one, let's get the derivative. So h prime of t, well, I see it's a fraction, so I would do my low d high minus my high d low all over my low low. And so we can plug those in. So I've got my low is the t plus 9. My derivative of the high would be 1. Minus my high, which is t minus 4. And then the derivative of the low is also 1. All over my low one, t plus 9, getting squared. And then we want to simplify that numerator. So we have h prime of t is, well, the 1 distributes. We'd have t plus 9. The negative distributes at the same time the 1 distributes. So we'd have negative t plus 4. All over t plus 9 getting squared. Okay, and then look at the numerator and we see, oh, t minus t is 0. 9 plus 4 is 13. So we have h prime of t equals 13 over t plus 9 squared. And then that is our fully simplified and factored derivative. So we found it. That's it. All right, and then now that we have our derivative, well, we set it equal to 0. But we have a special case. So in our step 2, if it's a rational function that we have as our derivative, we set both the numerator and denominator equal to 0. So set numerator and denominator equal to 0. So that's when we have a fraction. So that's because we had a rational function, which is a fraction. So anything you have something divided by something, this is what we want to do at this point. Okay, so let me put that up here. So step 2 still, I want to set the denominator equal to 0, and I want to set the numerator equal to 0. So I would have 13 is 0, and then I would have t plus 9 squared is 0. So this is how we get the critical numbers when it's a fraction. Well, 13 equals 0, this makes no sense. There's nothing to solve for. There's no t. No t to solve for. So that means we just move on. Also, 13 does not equal 0. This is a weird statement, so that's another reason just to move on. So this step is more important if there's still a variable in there. Keep going and solve it. With this one, well, it looks like I could square root both sides. So if I square root both sides, I would want to do plus minus on the number part normally, but square root of 0 is 0, and 0 doesn't have a sign. So it would be just 0 still. So I have t plus 9 is 0. And if I minus the 9 over, I get t equals negative 9. So this is the one critical number. All right, so it's where your numerator equals 0. It's also where your denominator equals 0. The numerator, though, was a very interesting case where it was really nothing to solve for. And so this is our one critical number. All right, and then now that we have our critical number, we still set up our number line. And I'm just going to plot the one thing that's on it. So this is really a t number line instead of x, but it works the same way. And I think in my last video, I wrote f and f prime, even though it was g. Okay, so that's just, typical letters to use. So it's not a big deal if we forget. So I forgot until now. I'm mentioning it now. But it would really be h prime and h really in this case. But it really is the same as just like if it's f and f prime. So it's no big deal if we use the same, or if you accidentally use the wrong letter. Okay, either way, we're just going to look at it and figure out where it is going, where our derivative is positive and negative, and that's where we still test out our values. So I'm going to choose anything bigger than negative 9, which I'm going to use as 0. So h prime of 0 So I'm plugging it into this. So 0 went in for this t. And then now I'm left with 13 up top over 0 plus 9, which would just be 9 getting squared. Well, that's 13 over 81. And this is a positive number. So again, that's all I care about. So that's positive right there. And then we need to do it with our any value less than negative 9. So let's plug in h prime anything less than negative 9. Let's do negative 10. So negative 10 is left of negative 9. So be careful of those. All right, with negatives at least. So negative 10 is left of negative 9. So it is smaller. And then I'm going to plug it in. All right, so I already did that t, and I have 13 up top. If I plug negative 10 into that t, I would have negative 10 plus 9, which is negative 1. But it's getting squared, so this would be 13 over positive 1. And 13 over 1 is still positive. So that means this is positive as well. So that means our function, the original function, so not the derivative, is increasing on our two intervals. Okay, so it never decreases. So we have this one only increases. So it increases from negative infinity to negative 9, and then from negative 9 to infinity. And again, separate it. So if you have a critical number, it needs to be split into multiple intervals. Don't just say negative infinity to infinity. So be careful of that. So and then let's add decreases. It never does. Okay, so if they still said, hey, where's the decrease? You could still say never. All right, well, here's what I want to break down with it. I want to look at my Desmos one more time. So you could always check. Remember in Desmos, it prefers x. So we would type this in as parentheses x minus 4 parentheses divided by parentheses x plus 9 parentheses. Okay, and we'll get our picture. Let's zoom out. And what we have here, and you might have noticed it right at the start, notice if you plug in negative 9 into the original function, you'd have division by 0. So that means we do have a vertical asymptote there. So at x equals negative 9, we do have a vertical asymptote. And we got that over here too in our equation, but it is a critical number. It is special to us. Okay, so that way we can see there is that asymptote. And then, well, reading it left to right, I see it would be going up. And it is, so even as far left as you go, it's still going up. Notice the y is getting a little bigger each time. Just barely, but it's still getting bigger. And so that means it is being drawn up from left to right. And then it goes up, 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 up. With the asymptote, it goes up forever, but it can't cross it. So that's why we have that break in our answer. So at negative 9, something weird's happening where it splits. And then we see, well, on the right side of that asymptote, it's still being drawn up from left to right. And that's why it's also still increasing there. Okay, so this is a graph that increases everywhere versus some of the other ones we see where it switches. Okay, so that can happen. It increased and never decreased. Okay, so that's what's nice about these problems with the calculator. Our number 4 was here. I usually forget to mention it. When we start to plug stuff in, I usually just go straight in the number line and start going at it. Okay, but that's that. So if you do have questions, please let me know. Otherwise, thanks for watching, and I'll see you next time.